example one and example two, I kind of drew from my own kind of knowledge base and whatever. But example three actually comes straight from your Mercer and Sabecki textbook. Okay. And I put this here because this is actually kind of challenging to read because it's a little bit small in terms of putting it into the notes. But basically what you see is, I'm going to zoom in a little bit. This is a record from 12 a.m. all the way to 12 a.m. again. So the complete day, hour by hour, and of an entire week of a student's schedule. And in this particular student, so they were told to record their hours of class time, homework time, sleep, work time, and other commitments, which includes free time. So a lot of people, they don't necessarily call things like, well, I have to take care of my siblings and I have to take care of my nieces and nephews. Like, what about me? Yeah. So a lot of people say free time is, like watching TV, like this is their Brooklyn Nine-Nine time. But some people, this free time, that's really vague. So when it says commitments, and that includes free time, so other commitments is like really what are you committed to outside of working, sleeping, homework, and school, basically. Like school, sleeping, and working. Okay, so here's some raw data, and on the next page of the notes, you'll see this question: complete the table using this student's schedule. I would actually recommend that you pause the video and do a count for yourself of all of these hours. Like, go ahead and count up how many O's you find in this entire chart. It actually took me 3 attempts to get it right, and because I just kept miscounting. So, FYI, recommended. Careful counting. Complete the table using the student's schedule. Here's what I ended up with. I ended up with 15 hours of class time, 32 hours of homework, which is actually pretty good. For every 1 hour you spend in class, it's recommended that you spend 2 hours of homework time. So this is a recommended balance. Sleep, 54 hours of sleep in a week. Work, they worked 15 hours per week. This is actually also pretty good. So this must have been the hypothetical dream student, where the student actually capped out at 15 hours of work per week. I know that a lot of students struggle with this particular category. Definitely in when they're at a community college. And if you work more than this, you were going to feel a struggle between doing well in class and trying to meet your professor's expectations versus doing well at work and your boss asking you to put in more hours and getting more pay. But, remember, at the end of the day, hopefully you find a good job. Nonetheless, and I know that's an awkward thing to talk about right now during a pandemic, because jobs, man, it's fierce and a little bit risky. So, nonetheless, 15 hours of work is a pretty good balance. Above that, then you're going to start to feel a little bit of you don't feel like you can satisfy anyone very well. Or do a good job at either. 52 hours of other business. And when we look at this and we total that up, I got a grand total of 168 hours. Okay, now let's look at how many hours are there in 1 week. All right, I'm going to do this in a conversion type of way because that will help you for the entire semester. So I'm going to actually write out all the details here. 1 week is our whole. So I'm having it as one, that is one whole, 1 week. And there are 7 days in a week. So 7 days to 1 week is a conversion factor into days. And then there are 24 hours. So 24 hours in each 1 day. Another conversion factor. And then what I have done is I've converted it into hours alone. This is actually called a unit analysis, and we are going to practice this a lot in this class. 1 times 7 times 24 hours is our whole. Okay, so after computing this, I get 168 hours in a week. Okay, so that's good to know. How many hours are there in a week? 168 hours, because that is how I knew I did this wrong 3 times. And finally, I got a total. I feel like it came out to 172. So I was double counting something a couple of times because I came out with 172, then 170, and then finally I got 168 total hours in a week. So I actually used this computation to check to see if I was wrong. And I was. So frustrating. But anyway, because it's just pure counting, and then you just don't know what you left out. Add another column to your table and write the fraction of time spent on each category in a week. Okay, so fraction out of the week. So I'm going to extend these lines. It is very challenging for me to make straight lines and parallel lines for that matter. Nonetheless, there, about. And fraction. Okay, let's do that. Add a column, fraction of time spent in each category. Okay, well, class time, 15 hours of the week out of 168 hours of the week. So 15 out of 168. Homework, 32 hours out of 168 hours in a week. 54 out of 168 on sleep. Work, 15 out of 168 total. And other, 52 out of 168. And then when we look at this total, this totals to 168 out of 168 hours of the week. Okay, done. Now add a 4th column to your table and write those as percentages. Show how you came up with your percentages here. Okay. Let's see. Percent. Let's go purple style. Percentages. Well, I would compute 15 out of 168, and that would be approximately 0.09 from the calculator, and then scale that up, and that is about 9%. So 9% on class time. And we would do the same for each one. So 32 out of 168 computed on the calculator. Let's see. So just to show you what I'm doing each time. So 32 out of 168. Okay. And I got 0.1904-ish. And multiply that by 100 because it's a percent is out of 100. So about 19% for the next one. So 32 out of 168 is approximately 0.19, which was 19%. Got it. Okay, and then quickly, 54 out of 168 is about 32%. And that makes sense. So in terms of 9 and 19, this is a little bit more than double. So 2 15s makes 30, and twice 10 is 20. So it makes sense that these are relative in size like that. Let's see what else. And 15, we've already done that. 15 out of 168, and now 52 out of 168 total. That is approximately 31%. And then we would total all of these. Okay, so let's do that quick just to verify. We got 9% plus 19% plus 32% plus 9% plus 31%. Totals to 100%. So that's nice. 100%. Got it. Okay, so add this fourth column, show how we computed the percentages. Got it. College students typically get 6.5 hours of sleep each night. What percentage of the day is that? Okay, so I need you to know the work we did in terms of percentages up here, that was out of the week. So this 168, that is not how many hours are in a day. That's how many hours are in a week. So this was 9% of the week. But here, this is percentage of the day. So let's compute that. First, I'm going to start with this 6.5. And my first job is to write that as equivalently, that's 6 5/10, which 6.5. Okay, so we really have 6.5 out of 24 hours in a day. 6.5 hours out of 24 hours. Okay, which is approximately 0.2708, which again, so if we round that, is approximately 27%. So what percentage of the day? About 27% of the day was spent sleeping, okay, for college students. Optimal sleep time for a person aged 18 to 25 is about 8 hours. Oh, I see. So, right, that age group I'm looking at. What percentage of the day is that? 8 out of 24, which simplifies to 1/3. Okay, and just to show you that, scale down by 8, scale down by 8. Okay, so take every 8 pieces, glue them together. Then 8 becomes 1 and 24 becomes 3. 3 groups of 8, if you will. And that is equal to 0.3 repeating, which is equal to 33 1/3%, or approximately 33% rounded. Okay, so I just need you to notice that college students typically get 6.5 hours of sleep every night, but they're supposed to get about 8 hours of sleep a night, and definitely there's a sleep deprivation problem happening there. Which, I mean, perhaps contributes to what I like to call the cranky student syndrome. It's totally made up. Anyway, still, you guys are never cranky. Never seen a cranky student in my life. Let's see. So, a couple of things that are remarkable about all of the stuff that we've done so far. First, percent. In my opinion, percents are used to make comparisons easier. So percent makes comparing fractions or portions easier without a common denominator. Okay, starting to slant here. It's true that comparing fractions, if you come up with a common denominator, is easy. For instance, let's suppose for fun we are ranking 53 168ths versus 52 168ths. Well, to me, it's clear that 53 is more than 52, and they are equally sized portions. So 53 168ths is more than 52 168ths. Okay, and now if we look at something like 1/2 versus 3/4, this one is also actually kind of easy in the sense that we could write 1/2 as 2/4, and 2/4 is definitely less than 3/4 if they come from the same whole. Okay, so assuming that we are comparing everything out of the same whole, and then, but let's suppose for fun we have something like 33 168ths versus 5/24. Okay, then now all of a sudden it's very tricky because these are smaller pieces, but there are more of them. And so you could come up with the common denominator, or you could convert these into percentages. I'm going to do that quick. So, all right, it's the best way to view the screen. You know what? I'm going to do this, even though it takes time to readjust for lighting. Okay, so 33 out of 168, and I'm going to scale up to make it a percentage. About 19.6%. And then 5 out of 24 scaled up to turn it into a percentage, 20.8%. So now I see that 33 out of 168, or 33 168ths, is a little bit less than 5/24, which was 20.8%. So percentages just, they make it easier for us to do quick comparisons. Okay, so in looking at this problem, so 33 168ths was a little bit less than 5/24, and we used the percentages to help us there. Okay, so, and just to write that in as reference, this was about 19.6%, and this one was about, what was it, 20.8%. Okay, so when I say that, when we keep computing these percentages, it's really much easier for people to view it as just to make a quick comparison, because they know that they are equal pieces out of 100. And 100 is easier for us to imagine as well, rather than 168ths. Okay, fractions. Remember that fractions are portions out of a complete whole. Okay, so in this particular case, the whole was the number of hours in 1 week. So here, the whole is number of hours in 1 week. There were 168 of them, we figured out. Excuse me. I have a tickle in my throat. And then the last remark I'm going to say about all of the things we just did is that let's suppose we pick one category. For instance, sleep. Sleep has a frequency of 54 hours. Oopsie. In the week. Okay. But that is out of the 168 hours. So out of 168 hours in the week. Okay, so when I think about fractions again, so 54 hours in a week out of 168 hours in the week, these have the same units, and so we could write them as direct fractions as opposed to a ratio of where the units would not be the same. So for instance, up here, when I wrote 7 days in 1 week, these had different units and I labeled them as such. That is not actually like a fraction per se, that is a ratio. And here, when I write something like 53 168ths or 54, it's funny that I use 53 when up here we had 52 and 54. But when we write these fractions, they have this like units, 54 hours of the week out of 168 hours in the week, so that we could call it 54 168ths. Okay, so just to bring you back to fractions and what they do for us. Okay, now let's take a moment to organize this into some bar graphs. It says that the horizontal should be the categories, the vertical should be the number of hours. So first thing I'm going to do is I'm going to actually write down my categories. Okay, we got sleep, class, homework, sleep, work, and other. Here's my legend, I guess. And let's follow the instructions. It says that the horizontal is categories. So the categories were activities done during the week. And the horizontal is number of hours in a week. Number of hours in the week, in 1 week, in a week. The quantifier, the, one, all mean one. Okay, and here we go. We're going to always start at 0, and we're going to list how many hours. According to our chart, 54 was our biggest count of hours. Okay, so we need to make sure our scale goes up to 54. If I count by 2s, 2, 4, 6, 8, 10, that would be 20. No can do. We got to get it up to 54. If I count by 5s, 5, 10, 15, 20, 30, 30, hold on, 5, 10, 15, 20, 25, 30, 35, 40, 45, not quite. So it looks like I'm counting by 6s. 6, 12, 18, 18 plus 6 is 24, 30, 36, 42, 48, and 54. Okay, counted by 6s. And let's go ahead and start drawing. Class, 15 hours. Okay, so I'm just going to use this as reference really quick. Here, maybe I'll put it over here so I don't have to keep looking back. Class time, 15. So right in between 12 and 18. Got it. Class. Homework. 32. Let's see. So that's just above 30. Okay, homework. Sleep. Sleep was 54 hours. Okay, all the way up here. Most frequently thing done. Sleeping. Gotta let your mind rest after all that serious thinking. Work. Let's see, 15. 15 again. Same as, what, class time? So, work. And other. 52 hours of other. Okay, done with that. 52. Okay, so just under 54. I don't know what kind of video games you're playing in this other category or whatever. All right, so it says horizontal categories, got it. Vertical number of hours, check in the week. And labels, got them, and a legend. The only thing I feel like that is missing from this bar graph is a title. When you are making a bar graph or reading a bar graph, you should be able to cover everything up around it and not have to read anything. So, like, you should be able to look at this graph, look at its legend, and have a really good idea of what it is representing without ever having seen the raw data and without ever having seen a chart or a paragraph. Because remember, all of that came from this. But we don't show that to someone, to the reader. We really show this because then you can visually see, okay, well, it looks like they spend twice as much time on homework as they do on class, same amount of time on class and work, and a lot of time on sleeping, the most. But that's followed by a little bit of like leisure or other commitments outside of work and school. Now, that being said, the one thing I feel like is missing from this is that this is a student's schedule. So maybe we could title this one college students weekly schedule. Just change my mind. There. For a title. That way we wouldn't need anything and we would know what was happening. Number 2, make a bar graph where the horizontal axis categories again and the vertical is percentage. Okay, so the only difference here is that this is percentage versus frequency or raw number of hours. Okay, so here we have the frequency and here we have a percentage or a relative frequency. So here we go. Activities done in the week versus percent of hours. So percent of hours in the week. Okay. And still we start at 0. And then it looks like in terms of percentages, I'm going to go back here. The highest percentage was 32. Okay, so what was it? Let's suppose 2s wasn't enough. Let's suppose we count by 3, 3, 6, 9, 12, 15. That would make the top 30. Nope, not quite. So it looks like we're counting by 4s. 4, 8, 12, 16, 20, 24%, 28, 32. Got it. Class time, 9%. So class, 9%, just above 8. Okay. Homework, 19%. Homework, 19%, so just below the 20 marker. Got it. Sleep, 32%. Okay. And if you're like, how is she coming up with those percentages? That's because we already did it, silly. We spent a lot of time on it. Right here. Yeah, we already computed all of these percentages. I'm not going to do it twice. Work. Work. This student spent 9% of their time on work, same as class. All right, 9% of their week on work. Same as percentage in class. And other. What was that? 31%. So just under the 32% here. Okay, and then you could title it the same. One college student's weekly schedule. All right, so let's take a peek at this and say, what do we notice about these bar graphs? Well, I don't know what you see when you see these two, but immediately I notice that they are practically the same. Maybe this one is a tiny bit shrinky-dink of this one, but it's proportional. And if we label everything right and we kind of draw it on a similar axis, then they look the same. And there's a reason for that. This one is proportional. So this one, even though it's out of 168, this one is out of 100, but it's scaled down appropriately. Both the numerator and denominator were scaled to be out of 100. So they should look the same, and we call that a distribution. Okay, so regardless of how you visualize these, or they should look exactly the same. Okay, so what do you notice about these bar graphs? They look alike. Bar graph. There are things that I think every bar graph should include, and there are 5 of these, so here we go. I'm going to draw this, but this is the horizontal axis, this is the vertical axis. Horizontal. On the horizontal axis, I expect the independent variable. Independent. Or in stats, a lot of times they like to call this the explanatory variable. Now, sometimes one variable doesn't explain another, so that will kind of not be a thing, but if you have this, then it is best to go by this. So if you have independence and dependence, then this is traditionally how we create our bar graphs. Along the vertical axis, the dependent variable, or in stats they like to call that the, oopsie, I forgot a letter, in response. Okay, so here's what I mean about independent and dependent. The percentage of hours or the number of hours in the week spent on something depends on knowing what category you're looking at. So independent is your category, but knowing the number and knowing the percentage, it depends on knowing what category you're looking at. Okay, so there's a relationship here. Knowing the percentage doesn't necessarily mean you know the category, unless you had the table here. But knowing the category, then the percentage depends on knowing how you categorized. Okay. I always judge and look for equally spaced increments. Equally Okay, so here I counted by 4s, and up here I counted by 6s, always starting at 0. We're going to write that down. So always start at 0. And last but not least, I judge on labels and title. Because you should be able to read a bar graph like this is good, not great. This is great because it has a title, knowing where this data came from, one college student's weekly schedule. I will judge you on your equally spaced increments. So if you went 0 to 8, then from 0 to 2, that space was a difference of 2. But from 2 to 8, the same space or the same distance represented 6. And there's a really big difference between 2 and 6. 6 is 3 times bigger than 2. And so I will judge you if you space things out in an awkward, unequal way. Basically what it does is distort the image. So if you had done that, these two images wouldn't look the same because one of them would have been distorted based on unequal spacing. Degrees of rotation. Okay, so none of this had to do with degrees of rotation. However, we are going to make a pie chart in a minute. So let's talk about degrees of rotation. This is a measure of angle. Okay, that starts at a fixed ray and rotates. And parenthetically, I'm going to say where one complete rotation is 360 degrees. Okay, and a lot of people reference a 90-degree angle. So just to have it as a reference, okay, so suppose this is our fixed ray, this is our hinge. I like to think of this as a door opening and closing. So here it is closed, and then we open it. And if it's a perfect right angle, that is 90 degrees of rotation, okay? If it were a super hinge, you might be able to collapse it all the way around. Or if you're a figure skater, skateboarder, I guess. I don't know, maybe you're a roller derby girl, whatever. Lady, woman, whatever. Okay, skater. I'll just call you skater. Leave it vague. But degrees of rotation out of 360. So let's look at this. Example 5 is the same data set, but this time we are looking at a pie chart. Here we go. Turn each of these fractions into percentages. Okay, we can do this. 0, 0%, a quarter, 25%, a third is about, well, it's precisely 33 1/3%, 1/2, 50%, 2/3 is, okay, double this, so 66 2/3%, 3/4, 75%, and 100%. Okay, so turn these benchmarks into percentages. Got it. Take each percentage from example 1 and describe how much each category of the time. This says example 1. I feel like that's a typo. I think what that means is example 3. Let me go back. Quick check. Yes, example 3. Okay, so I found a typo here. Let's fix it. Example 3. Take each percentage from example 3 and describe how much each category of time will take up of one circle. Fill in this table. Okay, here we go. 15 hours. So from the raw frequencies, how frequently did these happen? This many hours. Class, 15 hours. Homework, 32 hours. Sleep, 54 hours. Work, 15 hours. Other stuff, 32 hours. For a grand total of 168 hours in a week. We had also computed the percentages. I'm going to flip back and write them down here. Class was approximately 9%. Homework, about 19%. Sleep, about 32%. Work, 9%. Other was about 31% for a grand total of 100%. And then it says estimate what portion that is. Okay. Well, when I think about 9%, I go back to this half of a quarter business again. Half of a quarter is, okay, so half of a quarter would be 12.5%. So this 9% is actually even less than half of a half. So, okay. Or I'm sorry, half of a quarter. So less than half of 1/4. Got it. Homework, 19%. More than, so just under a quarter. Just under a quarter, which is 25%. Sleep. Sleep is approximately, it's pretty decent estimate for 1/3. Because that was 32%, that's close to 33 1/3. Work, same as class. So benchmark estimate, half of a quarter. Other, 31% is, I mean, it's closer to 33% than it is to 25%. It's off by 2% versus 6%. So I would again say that that is unestimated about 1/3. And 100% is the whole circle. Okay, so just to give a visual of what portions they should be. But now let's be really precise. Convert each percentage into degrees of rotation to get a more accurate portion of the circle for each category. Okay, in terms of raw frequency, again, 15 hours of class per week, 32 hours of homework per week, 52 hours of sleep done in 1 week, 15 hours of work per week, and 32 hours of other business to attend to per week. And let's compute degrees of rotation. Okay. I don't know your teacher's expectations, but certainly I like my students to show me exactly how they computed everything. So without this show of computation, I'd be like, I don't believe you. And here we are with this of business. 9% of 360 degrees. Convert this into a decimal. That is 0.09 or 9/100ths. Of indicates that probably multiplying of 360 degrees. That is approximately 32 degrees. So on this handy calculator, we go 0.09 times 360, 32.4 about. Okay, so, and then let's do another one. So about 32 degrees. And this 32 hours up here, 32 hours of homework was 19%. So for the homework degrees, I'm going to go 19% of 360 degrees, which is 0.19 times 360 degrees, which I compute to being about 68 degrees. Okay, so up here. Okay, and that should make sense because, again, 2 times 15 or double of 15 and you get 30, and double is 32 degrees and you should get 64. So this is a little bit more than that. That makes sense. Okay, I'm going to go ahead and fill in the rest of this chart based on doing the same computations, taking the raw hours, looking at the percentage, taking the percent of 360, and then filling this in. Okay, I got 115 degrees, 32 degrees, 112 degrees, and that makes approximately 360 degrees. Actually, when I totaled these together, I don't think I got a complete circle, so let's do that quick. 32 degrees, 68,